Hello and welcome to my science tutorials. In today's video, we want to look at linear inequalities. So without further ado, let's begin. Alright, so not all algebraic statements involve the equal to sign, and it is just as important to be able to handle algebraic inequalities as it is to be able to solve algebraic equation. Now, algebraic inequalities involve the inequality sign that is greater than, less than, greater than or equal to, less than or equal to. Now we also to note that the solution for an inequality is a range of possible values and not a specific value as in the case of linear equations. Now let's have a look at a typical example of a linear inequality. So let's say we have 5x minus 3 is less or equal to 2x minus 15. So this is a typical example of a linear inequality because of the inequality sign that we are having over here. So now let's try and find the possible values of x that can satisfy this expression that we have over here. Right, so solving linear inequality is just the same as solving linear equations, but there is a catch to it. Now, whenever you multiply through a linear inequality by a negative or you divide by a negative, the sign of the inequality has to change. I'll be showing you what I mean by that. So just like the way we solve linear equations, we are going to first of all group like terms over here because we have 5x here, we have 2x over here. So in this case, let me say this is case 1. Let's say I decide to maintain the 5x over here in the case 1 and send the 2x to the left side of the equation. So I have 5x over here minus 2x less or equal to minus 15. Then I send the negative 3 to the other side of the inequality, it becomes plus 3. So from here, 5x minus 3 minus 2x will give me 3x. I have my inequality sign. Minus 15 plus 3 will give me minus 12. So I divide both sides by 3 and by 3. So my x will be less or equal to negative 4. So this becomes my solution for this particular example. So it means my x is less or equal to negative 4. So it is negative 4 or less, but not greater than negative 4. So your answer will not be negative 3, it will not be negative 2, it will not be 0, it will not be 1, but anything negative 4 or less. Right, so let's look at case 2, the case number 2. Now in this case, I would want to, send 5x to the other side of the equation inequality. So I have 5x minus 3 less or equal to 2x minus 15. So let's say I decided to move the 5x to the other side. So I'm going to have minus 3 here. Then I send the negative 15 to the other side of the inequality. It becomes plus 15. Then less or equal to 2x. Then I send the positive 5 to the other side, it becomes negative 5x. So I have over here negative 3 plus 15 will give me 12. And this is less or equal to positive 2 minus 5x will give me negative 3x. Now I divide both sides by negative 3, negative 3. So this cancels this. Now the moment I divide by negative, the sign has to change. So it means that my answer here will be 12 divided by negative 3 will give me negative 4. So I have negative 4. Then because I divided by negative, the sign will change. So it becomes greater or equal to, greater or equal to. Then I have my x over here. Okay, so I can rewrite this equation by bringing x here and then negative 4 here. So if I do that, I'm going to have x is less or equal to negative 4. So this becomes my answer. Now we need to know that over here the inequality sign is facing negative 4. So if you are changing the position of the variables, it should also follow like that. Because over here we are saying negative 4 is greater or equal to x. It's greater or equal to x. It means that over here x is less or equal to negative 4 is also still the same thing. So this is our answer, as we can see. So it is the same as what we have in the first method. But in the second case, because we are dividing through by negative, we need to make sure that we change the position of the sign. Okay, so you can leave your answer as this, is still correct. But if you want to rewrite it and bring s first, make sure you have the inequality facing the number. All right, so let's have a look at other examples. So we have to solve the following inequalities. So we have I 5a plus 6 is greater than 2a plus 24. Then we have II 3b minus 5 is less or equal to b minus 1. Then I. We have 4 into bracket c minus 1 greater than 3 into bracket c minus 2. And then IV, we have d minus 3 into bracket d plus 2 greater or equal to 2 into bracket 1 plus 2d. All right, so let's go ahead and find the solution for these inequalities. So I write down my solution. I have 5a plus 6 greater than 2a plus 24. Okay, so I decide to maintain the 5a here and send the 2a to the other side. So I have here 5a minus 2a greater than, then I maintain the 24 here, and I bring the 6 to the other side, it becomes minus 6. So from here, 5a minus 2a will give me 3a greater than 24 minus 6 will give me 18. So I divide both sides by 3, both sides by 3. This cancels this. So a is greater than, because I did not divide through by negative, the sign still remains greater than. So 18 divided by 3 will give me 6. So it means that my answer, okay, or the values of a that satisfy this equation are all greater than 6. So from maybe 6.1, 6.2, 6.3, 6.4, or 7, 8, 9, 10, all those set of values from 7 above to infinity, they all satisfy this equation. All right, let's look at II. We have 3b minus 5 is less or equal to b minus 1. All right, so I'm going to maintain my 3b here, and I send the b to the other side, so it becomes minus b here. Then I have my negative 1 here. I send the negative 5 to the other side, it becomes positive 5. So over here I have 2b less or equal to negative 1 plus 5 will give me 4. So I divide both sides by 2 by 2. So my b is less or equal to 4 on 2 will give me 2. So this becomes my answer for the second expression. So let's look at I have here 4 into bracket c minus 1 greater than 3 into bracket c minus 2. Okay, so before we go ahead and do any rearrangement, we need to first expand the brackets. So 4 multiplied by c will give me 4c. 4 multiplied by negative 1 will give me negative 4. Greater than 3 multiplied by c will give me 3c. 3 multiplied by negative 2 will give me negative 6. Right, over here, I maintain my 4c here. I bring the 3c to the other side, it becomes minus 3c. Greater than minus 6. Then I send the negative 4 to the other side of the inequality, it becomes plus 4. So I have over here 4c minus 3c will give me c, and this is greater than negative 6 plus 4 will give me negative 2. So this becomes my solution for the third inequality. All right, so let's go ahead and solve the last inequality that we have over here. So we have d into bracket, we have d minus 3. Okay, so let's do that. Okay, so it is d minus 3 into bracket d plus 2 greater or equal to 2 into bracket 1 plus 2d. All right, so from here I maintain my d, I expand this bracket, I have minus 3d here, then minus negative 3 multiplied by 2 give me minus 6, greater or equal to 2 multiplied by 1 will give me 2, plus 2 multiplied by 2d will give me a 4d. So over here, I have d minus 3d will give me 2d minus 6 greater or equal to 2 plus 4d. Okay, so over here, I maintain my 2d over here. So I have 2d here. Then I send the 4 to the other side, becomes minus 4d. This is greater or equal to 2. I send the negative 6 to the other side, becomes plus 6. So I have over here, negative 2d minus 4d will give me negative 6d, greater or equal to 2 plus 6 will give me 8. Now I'm dividing by negative 6 to make d stand alone, negative 6. So therefore it means my sign has to change. So I have d. Now the sign will be what? Less or equal to 8 on 6 will give me negative 4 on 3. Okay, so this becomes my solution. Now if I want to write the negative 4 on 3 first, it means if I do negative 4 on 3, then I have to change the sign from less or equal to. The sign has to face this guy again before I write the d. So these or these are the same, but it's always preferred if you write your unknown quantity or your variable on the left hand side and then your answer on the right hand side. So you can leave it like this without changing it like this, but either way, these and these are all still correct. So thank you so much for watching this linear inequality video, and in the next video we'll be looking at quadratic inequalities and how to solve quadratic inequalities. So thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve quadratic inequalities. So without further ado, let's begin. Now, for you to be able to solve a quadratic inequality, you need to first of all write the quadratic inequality in the standard form, that is in the form as squared plus bs plus c. After writing it in the standard form, you need to determine the root of the inequality. Just like the way we find the root of a quadratic equation, we do the same thing for the inequality. But after finding the root of the inequality, we need to write the solution in an inequality notation. And I'll be showing you how we write the inequality notation very soon. Right, so let's have a look at an example to appreciate what we are about to do today. So we are to solve the inequality x squared minus 4x greater than negative 3. So this is the inequality that we have at hand. Now for us to solve this inequality, we first of all need to rewrite it in the standard form. So that means we have x squared minus 4x greater than negative 3. We have to move the negative 3 to the left hand side of the inequality, so that this will be greater than 0. So we have x squared minus 4x plus 3 is greater than 0. Alright, so from here, we need to find the roots of this inequality. So to do that, we use the coefficient of the x squared term to multiply the constant, which is 3 over here. So 1 multiplied by 3 will give us 3. Now, which two numbers will you multiply to get 3? But if you add or subtract, you get negative 4. So if we think very well, negative 3 and negative 1 will do that for us. So negative 3, negative 1, if we multiply it, we get positive 3. But if we add, we get negative 4. So we have over here x squared minus 3x minus x plus 3 is greater than 0. So from here, I can go ahead and do my factorization. So I bring x out over here. So I have x minus 3 left for these two. Then I have between here x and positive 3 minus 1 is common. Then I have x minus 3 over here greater than 0. So I have over here x minus 1, then x minus 3 greater than 0. So I have x minus 1 greater than 0 or x minus 3 greater than 0. So therefore this means that I have my x to be greater than positive 1 or my x to be greater than positive 3. Now if we look at this is not our answer. If we look at this side of the equation, this side of the inequality, we are having what is on the left hand side, which is the x squared minus 4x plus 3, to be greater than 0. Now, if something is greater than 0, it means it's positive. So it means the corresponding y value that we are looking for, the y value that we are looking for is supposed to be positive. So in this case, y has to be positive. Now let's look at how we derive our answer. We have this x to be greater than 1, x to be greater than 3. So let's plot the graph. So if we plot that graph, we are going to have something that looks like this. Okay, so we have positive 1, positive 2, positive 3, 4. And I have negative 1, negative 2, negative 3, and negative 4. Now, if I look through these answers, I have 1 and 3. So 0.1 and then 3 over here. Now, for an inequality, instead of having the parabola curve, we have a straight line going through. So we are having our line passing through 1 over here, and then another line passing through 3. Okay, so this is how the graph is going to be like. Now, are we looking for a solution that lies between outside, let's say 1 over here towards the negative, and then from 3 towards the positive, or the answer is between 1 and 3? Let's look at that. Now, because y from this side is positive, or this is greater than 0, it means that our solution should lie outside the curve, the straight line over here. I take that again. Because this guy is greater than 0, which means it is positive. So because y is positive, okay, by y I mean x squared minus 4x plus 3. Because that part of the equation is positive, we are looking at the x values that will give us y to be positive. That is, we are looking at the upside over here, outside over here. Okay, those are the parts that we are looking for. Now, if y were to be negative, that is less than 0, then we'll be looking at in between 1 and 3. So we'll be shading the inside. So for this particular graph, let me use another color. So our graph will be shading the outside over here. Okay, we'll shade the outside over here. So it means our answer lies at this side of the graph, and then also at this side of this graph. Okay, so if you plot this graph in Desmos, if you plot this equation in Desmos, you're going to have a graph that looks something similar to this. Okay, but they will have here shaded much more beautifully. Anyway, that is just by the way. Now, what is the inequality notation over here? The inequality notation over here is that we have x, that is, okay, because over here from 1 downwards is less than 1, and then over here x will be greater than 3. So our inequality notation over here will be x less than 1 or x greater than 3. Okay, so x greater than 3, it means we are looking at this direction, so this side of the equation, and then s less than 1, it means we are looking at from here all the way down to the end over here, or to infinity. So it means our solution lies outside over here. So you can try that out. If you pick any number below 1, that is maybe 0, -1, -2, you realize that this side of the equation will be greater than 0. If you pick anything above 3, you realize that it will still be greater than 0. But if you pick anything in between 1 and 3, let's say 2, if you substitute 2 into this equation, you are not going to get the value to be less than 0, to be greater than 0. So it means we want answers that are outside the curve over here. So this becomes our answer. Note that this is different from this we are having over here. So we can see that this side is maintained, but this the sign changes to less than instead of greater than. So after factorizing, the roots are not your answer. You need to try and draw the graph, understand how the inequality will behave, and then you find your solution set or your inequality notation. All right, so let's go ahead and solve more examples to really appreciate what we are doing. So the next example we want to look at is s squared minus x greater than 12. Right, so because we are having a greater than sign, it means we are expecting our y to be greater than 0, which means it will be positive. So we are looking at the answer will be extremes of the 2 points that we are going to get for x. So let's look at that. So we have this, we rewrite this as x squared minus x minus 12 is greater than 0. Now we use the coefficient of x squared here to multiply negative 12, so we have negative 12. Now 4 and 3 will do this job for us, so we have x squared minus 4x plus 3x minus 12 is greater than 0. So over here I can factorize x out, so x outside bracket x minus 4, then I have here plus 3 into bracket x minus 4 greater than 0. So I group s and this positive 3, and then I maintain one of these root s minus 4 is greater than 0. So I have over here from here s plus 3 is greater than 0, or s minus 4 is greater than 0. So from here it means I have s greater than negative 3 or s greater than positive 4. Now, like I said, after finding your roots, that is not the solution. Let's go ahead and try and plot this graph and see what we are going to get. Now, so if we draw this graph, we have, let me quickly label the answers. So I have 1 here, 2, 3, 4, let's say 5. I have negative 1, negative 2, negative 3, let's say negative 4. Now, if you look at this equation, you realize that this side of the equation is positive since it's greater than 0. So it means y is positive. Y is positive. Now, if y is positive and we have the two extremes, which are negative 3, so our line will pass through negative 3 over here, and then the other one will pass through 4. Now, because y is positive, we are looking for values of x for which the graph will be above the x-axis over here, or the values of x for which y will be positive. Okay, so for those values, it means that we are looking at the extremes. Because this is positive, the values that lies below negative 3, and then the values that lies above 4 are going to be our solution set. So if you plot this graph in Desmos, so you can download Desmos app on your phone, or you go to desmos.com and you plot this equation, you are going to have a graph that looks something like this, and this side will be shaded. So if these sides are shaded, it means y is positive. So the values from negative 3 below, and then the values from 4 above will give me a positive y value if you substitute them into this equation. So my solution set is therefore s less than negative 3 or s greater than positive 4. So this becomes my solution set. So this is my answer for this particular equation over here. Not this guy, but this guy is the solution set. And I'm explaining how we got this, because I said if you look at this side of the equation, it is greater than 0. For that means y is positive. If y is positive, you shade the extremes of your graph. But if it is negative, you shade within. It means your answer will be within. So we'll have a look at an example where it will be within. All right, so let's have a look at another example. So we have two s squared less than 9s plus 5. Okay, this is a very beautiful example. Now, let's try and solve this problem. The first thing we do is to rearrange this equation to write it in the standard form. So I have 2s squared minus 9s minus 5 is less than 0. The fact that this side of the equation is less than 0 means that our y will be what? Negative. Okay, if 0 is greater than anything, it means the thing is negative. So this equation is telling us, or this inequality is telling us, that y is negative. Let's have that in mind before we continue to solve. Okay, so from here I need to factorize this. Now 2 multiplied by negative 5 will give me negative 10. Which two numbers will I multiply to get negative 10 but add to get negative 9? We don't necessarily have any two numbers that can easily give us that. So we are going to be using the quadratic formula to solve this. So my x is equal to minus b plus or minus the root of b squared minus 4ac all on 2a. So my s is equal to minus b. So my b is minus 9, which is the coefficient of x. My a is 2, the coefficient of s squared. And then my c is negative 5, which is the constant. So I have here minus b, so it will be minus into bracket minus 9 plus or minus the root of minus 9 squared minus 4. The a is 2 multiplied by negative 5, which is c, all over 2a. The a is 2 here, so let me do that. So I have my x is equal to, this becomes positive 9 plus or minus the root of, if you simplify everything we have under the bracket over here, you get 121 divided by 4. Okay, so root of 121 is 11. So I have s is equal to 9 plus or minus 11 on 4. So my x is either equal to 9 plus 11 on 4, or s will be equal to 9 minus 11 on 4. Now 9 plus 11 will give me 20 on 4, and this will give me 5. Or 9 minus 11 will give me negative 2 on 4, will give me negative 1 on 2. So I have these two values. Now remember, we are dealing with inequality, not equation. So s is not equal to, so we bring the inequality sign back. So it means s is less than 5, or s is less than half. Okay, so this is the factors or the roots. Now from here, it means we need to plot our graph or draw our graph. So let's do that. All right, so let me just use this small space over here. Okay, so I have 5 and then negative half. So let me redraw this graph well. Okay. All right, so let me shift the y-axis here. So let's say this is 1. So our half is somewhere here, negative half is somewhere here. Then I have here 1, 2, 3, 4, and 5. So my line is going to pass through 5, and then it will also pass through negative half. So it's going to be like this. Now remember, when I was solving this equation over here, I established the fact that because the left hand side is less than 0, it means it is negative. Because it is negative, our solution lies in between the negative half and 5. So this is how our graph is going to be like. In between negative half and 5 will be shaded. So it means my s lies between negative half and 5. So I will have my solution for this particular example to be negative half less than s less than 5. Okay, so this becomes my solution. Because if you look at it, negative half less than x, so anything less than negative half and less than 5 will give us the solution. So if you substitute, let's say 1 into this equation, you are going to see that it's less than 0. If you substitute 2, it will be less than 0. But if you substitute, let's say negative 1 into this equation, it will be greater than 0, which means that anything that lies beyond negative half are below, and then positive 5 above will not be part of this equation. So this becomes our answer. All right, so let's have a look at one final example. So example number 4. So we have 2x squared plus x minus 15 is less or equal to 0. Okay, so let's go ahead and factorize this, since the equation is already in the standard form for us. So we have 2x squared over here. Now 2 multiplied by 15 will give me negative 30. That negative 30, which two numbers will I multiply to get negative 30 but add to get 1? So I will have 6 and 5. So positive 6, negative 5 will do that. So I have 2x squared plus 6x minus 5x minus 15 is less or equal to 0. Now, if something is less or equal to 0, it means that we are expecting our y to be negative. Okay, let's note that. Since this side of the equation is not greater or equal to 0, it means our y is negative. So it means we will be shading in between the two values of x that we'll get for this quadratic equation. So that is something you should note down. So always try to see whether it will be y will be negative or positive. That will tell you where to shade. Okay, so let's continue. So we have 2x common here. So I have 2x into bracket, x plus 3 here. Then over here I have minus 5 common, then x plus 3. This is less or equal to 0. So I have here 2x minus 5, and then x plus 3 is less or equal to 0. So from here I have 2x minus 5 less or equal to 0, or x plus 3 less or equal to 0. So 2x less or equal to, I send the 5 to the other side, it becomes positive 5. Divide both sides by 2, my x is now less or equal to 5 on 2, or this is 2.5. Or over here I have x less or equal to negative 3. Okay, so let's go ahead and draw our graph to see where our answer will be. Okay, so I have here negative 1, negative 2, negative 3, negative 4. I have here 1, 2, 3, 4. Okay, so I have 2.5, positive 2.5, so something around here, somewhere here. Then I have negative 3 over here. So my graph will pass through negative 3 all the way down, and then 2.5 all the way here. Now, because I established over here that y is negative, because if you look at this equation, we are saying that it's less or equal to 0. So it means y should be negative. That implies that we have to shade inside of these two lines. So this is where our solution lies. It lies in between over here. So it means my x is in between negative 3 and 2.5. So my solution over here will be negative 3 less or equal to x less or equal to 5 on 2. So this is how we solve quadratic inequalities. First of all, we rearrange the equation in the standard form. We try to find the roots. Now with that roots, we draw a graph, okay, plot the jot where the 2 points that we have for as the factors, or as the zeros of the equation. We tick them and then draw a straight line through them. Now we have to consider the equation. If the equation is greater than 0, it means y is positive. So we paint the outside of the graph, outside the two values that you get. But if it is less than 0, something that is less than 0 is negative. So you paint in between the two lines that you've drawn, and then you write the solution set appropriately as required of you. So thank you so much for watching, and I will see you in the next video. Bye bye.